So gentlemen, we're going to talk about sizing heating systems, energy loads, heating profiles, building performance, and really how this advent of hash rate heating putting Bitcoin miners into homes and businesses, why that might be important to consider and how that factors into any analysis that you guys are already doing or dealing with. But before we start with those questions, why don't you just start, Mike, introduce who you are, what you do, how you think is kind of related to this summit, and then we'll move our way down.
Yeah, I'm a sales engineer. We're an equipment rep, so I sell commercial HVAC equipment in Colorado. So I think that's pretty applicable to what we're trying to do here. We've talked a lot about, the residential side, the large industrial side, and the commercial side, kind of in the middle.
Sure. Hey guys, I'm Dan Luddy. I'm based out of Seattle, Washington. My day job is as a building performance consultant and mechanical engineer with affiliated engineers, and I have a side consulting business called Portside Research, where we look at emerging technologies and how they impact the built environment. And a lot of my focus in my career has been on sustainability and decarbonization and electrification. And so I see this as being sort of adding to not only sustainability sort of on the environmental reason, but also sort of financial sustainability as well.
Yeah, and I'm Andrew Krippner, CEO of HVACer, and we build cloud collaborative design software for HVAC engineers. So I think that's really relevant because the load calculations and energy modeling enable you to predict what your investment will do over time, depending on where you're at and what kind of equipment you're using. So a lot of the conversation, I've had a ton of great conversations over the last 3 days. I'm super grateful to be here. A lot of it is my position is how do we cross the chasm. A lot of you maybe read that book, Crossing the Chasm, talking about the nerds here, the techies that are the innovators, and then the early adopters are maybe all of your friends who maybe you like install a hot tub at or whatever. And I think we're at that point where you're trying to look at this giant chasm in front of you between where you're at and thousands of HVAC engineers that use a platform like ours. So hopefully we can help bridge that gap.
Yeah, so let's set the stage a little bit, describe it for the folks who perhaps aren't as aware as us and me trying to learn. These tools, from what you're working on, Dan, I'd like to hear a little bit the difference of like a design condition where the software might just say you need a machine this big versus where a load profile comes into play, what the differentiators are. And is the goal of both of those just to get the best bang for your buck heating system? Is that the name of the game, the current status quo?
Yeah, so to start with, when we're looking at peak sizing, you're basically looking at the most extreme condition where it's the coldest temperature you'll ever get outside. No one's in the space, but you're cranking the heat as high as you need it to go. None of the equipment's on, like the maximum amount you'd need, and so you're sizing your boiler for that amount, and it will basically never run at that 100% factor, especially if you have an oversizing, which every engineer does. When we're looking at a sort of load profile, we're looking at an hourly estimate throughout the year, and we're looking at the impacts of the scheduling of your building, the internal loads that you have, and really trying to understand what's the sort of minimum heating amount that you'd need during the swing seasons in the winter months versus the sort of peaks and valleys that you get throughout that profile. And so that comes into play when we're sizing different types of heating equipment together. If you have, like, say, a heat pump system with a supplemental backup boiler, you want to be able to run, or a hash rate heating system, you probably want to run that as continuous as possible, sort of have that base load. But then if you do have those peaks, it can be sometimes more advantageous to just put in a cheap, dumb sort of electric resistance backup to handle those loads. And really looking at the differences there so you can anticipate what you'd expect to see through that annual year.
And is this done only for high-performance buildings, large commercial, industrial up, and then jump in after, Andrew, because I want to hear where your software comes into play and what it's targeting in terms of analysis?
Yeah, to start off, I'll say it's more common in larger buildings when, particularly if we are doing an energy model anyway to look at the sort of energy output that you'd expect for the building and looking at ways to save or potentially for code compliance reasons. The larger projects will be able to afford that. That being said, I think there's ways that smaller projects can either put something together pretty quickly. The software tools that are coming out and are available now are light years beyond when I started my career. Even just hacking something together in a spreadsheet you can do pretty readily.
Yeah, well, my thoughts are that there's many reasons why someone might set up a system like this, and the analogy I was thinking about yesterday was the early days of solar, and during those days there were these zealots who would install a system because it was kind of a virtue signal for them to show that they were engaged with the climate and thinking about green technology, and even if it wasn't an economic ROI for them, they would want to do it. And I think there's a lot of people in this room who are virtue signaling their little gizmos and gadgets, and that's fine. I'm not like, putting that down or anything. But in order to cross the chasm from you guys to like a commercial scale that's actually meaningful, that's going to actually create the future of decentralized mining and heating, then you actually have to prove an economic ROI. And that doesn't change in a commercial setting versus residential or whatever. It's that you have to do math and simulate what's going to happen in order to make sure that there's utilization. And to your point, I was just thinking about other investments that you're making. You wouldn't buy an apartment building with 10 units if you knew you were only going to occupy 3 units. And I think that analogy is just showing you don't want to spend money on all these miners that are off all the time because your load doesn't call for that amount. So if you size it according to that peak, then you're going to be wasting a lot of your capital expenditures. So it doesn't really matter where. If you're looking for economic ROI, you have to do math.
And once these models are done, the math is done, that's when it comes to you, Mike, and people are specifying changes at the hardware level for some larger commercial applications of heating and air conditioning. Tell us how that works.
Yeah, that's correct. And just to jump on that, HVAC equipment, air conditioning equipment is great, right? It works. It works really well. We're not really disrupting, HVAC heating, cooling technology. It's more of an economic disruption. It's a new framework to think about this. And so exactly what these guys are saying is going to be so important. We've kind of harped on needing the form factor of the equipment, all the documentation for submittals, wiring diagrams, installation manuals, those things, but being able to do an economic analysis and sell that to an owner or building operator and not rely purely on price speculation is going to be so important. For the equipment side, as an equipment rep, we work with consulting engineers to kind of educate them on products specifically and help them size the products based on the load calculation that they come up with for that specific building or home or whatever it is. And then we physically go and sell that equipment to the contractor.
So just to double click on this sizing thing, I mean, what we're alluding to is that you don't want to size the Bitcoin heater for that coldest day, because that coldest day is once a year. And you end up buying a bunch of Bitcoin miners that you don't use, and your ROI is killed, and your CAPEX is humongous. So it's this notion of kind of base load. That's where the economics come in. On sizing, I get that. It's just a BTU number, right, that you're looking for, or a profile. What about the Bitcoin economics? Do you guys foresee that it's even feasible to, offer an expansion pack for certain softwares, or a version for the Heatpunks out there that are trying to learn these skills? How does that play out? Because effectively how I view it is there's 2 big new knobs. Like with heat pumps, the knob is your outdoor temperature, and that changes your thermodynamic efficiency. But with hash rate heaters, your knob is what's the fiat Bitcoin price and what's the mining network difficulty. 2 giant knobs. Let's start there, just like moment in time, but then also when you're doing energy load profiles, which are inherently time-based, right, throughout the year, you have to make some prediction about how those 2 knobs change over time, which is another dimension. So jump in wherever and you'd like to talk about that, because I think it's a huge challenge.
Yeah, and that's what I'm currently sort of pounding my head against, is that idea of adding the additional complexity of the sort of revenue stream that you might get back. We do life cycle cost analysis when we're proposing different mechanical solutions already, and those inputs, you have knobs you can turn, and we've started to evolve from just giving an owner an answer, this will save you this much money per year, to here's a range depending on what you think the outlook looks like, depending on the different sort of financial perspectives. of what's coming in the next 5 years. And so this, to your point too, it adds a level of volatility and complexity to that, which I guess gets to the mindset of the owner or the design team that you're talking to, and what sort of receptiveness do they have to that additional risk, and how you present it, and also how you're delivering it. Are you just delivering the equipment and they will take on that risk and that volatility, or are you just delivering the heat to them and then you keep that as well? And that informs, that has to go into your model as well, your financial model.
Andrew, as a software designer that sizes heating systems, we had a call a couple months ago, maybe a couple weeks ago maybe, talking about with your co-founder, Davis, load profiles, and I showed you how our model worked to bake in all these Bitcoin economics, and you were like, this is easy, you guys aren't that smart. But what would it take to build that? Because I have a feeling all the customers of that software are in this room, and that's it. How are you thinking about this?
Yeah, that's a good question. I mean, as far as the economics of the Bitcoin itself, I suppose all of the miners here are very familiar with that. And you're already, I mean, you're spending fiat basically to invest into the tool to create Bitcoin, right? And part of that model is how much you're willing to speculate that the price will go up. And I suppose that's not a novel concept here. So just the fact that you're using that same tool in the context of heating, to me, the thing I'm thinking about is Bitcoin mining is kind of like a search function for the cheapest electricity. You're looking for the cheapest electricity. And you're basically, by using it in heating, is getting the double spend of the BTU and BTC. You're basically just effectively reducing your cost of the electricity. I feel like I went a little bit off track of your original question.
You can still save it.
No, I weave.
Okay,
I come back. It's not quite that good. But yeah, you started, like, what would it take from a software perspective? Well, first of all, if any of you want to do a load calculation and just like talk with us, I'm willing to do that. It's not our core business, and we, operate much more in your guys' world, in the traditional commercial HVAC market with sales engineers and manufacturers, and it's this complex thing. But if you want to talk to me about load calculations, I'm willing to do that. But yes, so your original question was our software is not currently set up to be optimized to spit out, okay, you should get this many miners and here's your ROI payback and everything, because we haven't built software for Bitcoin mining sizing. It is a niche. But if you call me and we start talking and it becomes really readily apparent that this is so important, we have to do more.
Well, I
then
guess
we
that's
can
my
start
question
building,
is this functionality in these known and loved software for sizing, is it necessary for the commercial applications of hash rate heating to be treated as a viable option? In all three of your guys' opinion, just work your way down. I'm curious if you guys think it's an important, necessary step.
I would say yes, but I've been talking too much, so I'll pass it off.
I'd say yes too, and I think the thing I'd add to that is that, well, with any of these models, and I think there's a saying I keep that's kind of famous, is like, all models are wrong, some more than others. And I say that as an energy modeler.
And some are useful.
Some are useful, yes, thank you. So it's always just one piece of the conversation that we have, and it also matters, like, to have a broader discussion about the parameters of the mechanical system and what the owner needs, and have a discussion around what sort of space do you have, what sort of temperatures do you need, do you have a noise requirement in your neighborhood, like all these things, and kind of weight those different factors to the decision making as well. And so yeah, I think it does matter, but you have to kind of place it within that broader discussion.
Yeah, I think it matters, and thinking about where does it belong, right? Like, where does that software belong? And like I have access to dozens of software to size and select equipment, and we're taking, input from the engineers that they're outputting from their software, right? So who builds that software to size the miners is a good question.
And
The mining, typically it's like the equipment manufacturers have a software to size their equipment based on the loads.
it comes from the manufacturer themselves.
Right, but I don't think well, I guess there are,
I don't think Bitmain will do it.
Yeah, that's what I was getting to. I don't think they're gonna be creating a sizing software. Maybe Exergy could.
Well, let me ask you this then, Mike. Do you think that a tool like that, sizing from the manufacturers, that seems like almost to me, are we getting ahead of ourselves? Is it a step that comes later when we had guys up here on stage earlier today talking about can we just get, a certification on this thing? Can I see what's in the circuit board layout? What firmware is on this thing?
Yeah, I think we don't need it now, right? We need to prove the, economic side with what Daniel's doing to sell owners on it, right? And prove that it's going to pay off over time, and it makes sense in their application, because it's not going to make sense everywhere, right? Cold climates, that have very long heating hours, it tends to make much more sense, right? Than compared to a milder climate where maybe you throw in a heat pump with a high COP and you're not using electric heat as often. So.
Yeah, correct me if I'm wrong, gentlemen, but for the people unaware in the room, a heating load is really, you're measuring your duty cycle every hour of the year, effectively. And that equates to how much energy you use, which you can convert to an amount of terahash that was online, which you can turn into amount of sats, theoretically, off of hash price is how I understand it. What about hybrid systems? Anyone can jump in here on this. That sizing for Bitcoin miners, because they're expensive digital computers, complex internet-connected hash rate heaters, targeting more for base load, the average amount of heat you need because they're going to be earning revenue, it justifies paying more. You still have the backup dumb heater, so to speak, for the peak condition. Is that an obscure notion? Is it totally normal to have hybrid systems like this optimized for that kind of base load, peak load setup?
Oh yeah, and we're kind of going through this right now with large air source heat pumps have become much more popular. There's a race for reps to find manufacturers of large scale 100-ton plus air source heat pumps due to this whole push of electrification, and I think there's been a lot of battle stories of installations, and I think that they're finding it is best to size it for base load and then have a backup boiler system if you can, right? So, and I'm sure you have some experience with that as well.
Yeah, I'll say we see it all the time with often buildings like laboratories that have a lot of heat that's generated anyway. There's sort of water-to-water heat pumps as a first stage that'll reuse that heat where possible and just scavenge it, and then particularly an air source heat pump backup, and then maybe even a third stage of an electric boiler or gas boiler backup beyond that. So part of what our energy analysis and load profiling does is be able to size those different components and also look at the different control schemes and when you would call each piece of equipment to come online and kind of figure out and work with the design engineer to come up with that sequence of operations of what's going to optimally work, not just from providing that load, but just have the best sort of energy and cost performance.
Yeah, and I would kind of extend on that and be a lot of times you have multiple pieces of equipment in a system, but even if you look inside of the equipment, there's a lot of different coils and processes happening inside that box. So it's not just you've got this BTU per hour at this time of day in a building. It's maybe more complicated than that, because a lot of times, I think a good example is maybe VAVs with reheat in a humid climate. You want to drive the temperature of the air down below the dew point to get condensate out of the air to remove humidity. But then if you get to that temperature and dump that into the room, it's maybe too cold. So this is heating during cooling. You're actually cooling, but you'll put reheat after that cooling coil to bring it back up to a comfortable temperature. If you look inside that box, that might be a better place or more appropriate place for a Bitcoin miner to exist, is because it's on very often, even during the cooling condition. So it's not just hybrid systems in the sense that there's different equipment, but you have to have an engineer's perspective on the physics, the psychrometrics, everything that's delivers the system.
What's actually inside the box? Because even something I keep hearing and being suggested is a lot of heat pumps have electric resistive backups inside of them for when it is that extreme cold scenario. Now it's kind of backwards. It's extreme cold under the peak condition, not base load. It's ideally how it should be sized, but I see what you're getting at. I do have a question about back to the modeling front and the economic and the ROI assessment. Dylan and I spent a lot of time diving into this, specifically for that Lions project that Bart was up here talking about earlier for a commercial build. I mean, effectively, over a 25-year construction loan, we're being asked what I think the Bitcoin price is going to be in 25 years. and then we put that in front of a bank and we say, give us a loan. But how it relates to you guys is in that model, over 25 years, unlike traditional heating systems, if hash rate heating manifests, you're going to want to upgrade that heating element. Because effectively what these things are computers that make money, but then every year they start to lose their slice of the pie as more miners come online and the network continues to grow. And so there's this upgrade cycle in a sense. And ideally it should be longer than the data center style because you're not seeking profit as a Bitcoin mining operation. It's just a subsidized heating operation. I'm curious, does that play into the energy modeling, or is it like a one-year thing that you look at, Dan? I mean, does it happen over a long time frame? How does that play in for us when we have to consider upgradable heating elements to refresh how much money they make?
So that we will take our results from the energy model, that's sort of an annual look at the usage of the building, and then we'll feed that into a broader life cycle cost assessment that will go for 40 years or something. And so where that will play into is that'll increase the sort of operations and maintenance cost for the equipment. And that will, you'll have to account for that there. And yeah, that's where I think it's gonna be challenging. If we're looking at this sort of 25-year, or even less than that, some owners would wanna know like what it looks like in 10 or 5 years. I can't go to them and say like, Bitcoin's going to 10 million, bro. Like, just trust me on this one. Like, you have to have more robust analysis or more scenarios that you're looking at so that you can make them feel comfortable across, independent of the price that we see, and know that it's a good decision otherwise.
Any thoughts from Mike or Andrew on that?
Well, I think in another panel, there was probably a discussion about who gets the rewards, and there's probably a way to abstract that away from an owner, a developer, is probably just to underwrite your own risk tolerance, and you're the one probably writing the rebate to them, and then you're accepting the Bitcoin reward, so that it's not this mixed, you're not selling them heating and the concept of number go up at the same time, which is probably too hard to conceptualize.
Well, it kind of makes me think of like the ESCO model that other sort of mechanical and electrical firms will have, where they'll guarantee a certain energy savings if they come in and make some upgrades, and then they'll recoup their costs based on the savings over time, as opposed to charging you up front for the cost. So there's different ways of approaching the finances. So interesting for me is that we kind of have to blend a lot of this different financial scenarioing into the way that we're looking at the output of the heating system, and kind of marry the energy modeling and the financial analysis much closer together.
Yeah, understanding what's important to the owner. I mean, it sounds obvious, but is maintenance, limited maintenance very important to them, right? Like how long do these chips last? Like 5 to 6 years. An electric resistive heater could last like 30 years, with very minimal to no maintenance. So, are they upfront cost sensitive? So I think just understanding what's important to your owner operator is really important in all of this.
Yeah, as much as I wish it were true, I mean, we have to remind ourselves that hash rate heating doesn't solve all problems. It can solve some problems, and it doesn't make sense for all. I want to touch on actually how I have found sizing to work on the more residential side. And I understand you guys have different levels of experience here, primarily on the commercial side of things, but my experience through learning this as an outsider has been, it's pretty much all finger in the wind rules of thumb. Do we need to come up with those for hash rate heating on the residential side? Just given your experience and your background, do you have any thoughts on that? Because, for example, this peak versus base load sizing, Dan, maybe I've heard for radiant heating, try to target 30 BTU per square foot, but the way we ran the math on this building with that boiler, it's more like 11. So it's a third of that, and it would be overkill to do the 30. So what comes to mind in that sense?
Yeah, I think it's helpful to have some sort of basic rules of thumb to start the discussion. It's sort of the vernacular that a lot of engineers use. Particularly, we get asked early in a sort of conceptual stage, we're going to be building this hospital. We don't even know what it's going to look like, or we just know it's 100,000 square feet. What's the EUI going to be? What's the, tell us about what sort of mechanical systems make sense. And so we have to rely on some other metrics or previous experience to kind of come up with those initial thoughts. So having rules of thumb just kind of can help inform the initial discussion before you have time to do a more robust analysis on top of it. So I think someone mentioned one of the other panels, like sats per square foot, like some of those metrics would be really interesting to see.
Yeah, when it comes to sizing, I've always been under the impression that rules of thumb are dangerous, at least in the commercial world. And we try to stay away from handing those out because they love to come back and yell at you said it was X dollars per ton.
And it's why everything's oversized, too.
Yeah. Which is very important in this discussion, is not oversizing your miners, especially if upfront cost is important.
For context, the furnace on this lounge side over here has a Canaan Avalon Q ducted into it. That's 1,800 watts. It's not that much power. It's like 10 times less BTUs than the actual furnace. And we've been measuring, and since we installed that 2.5 months ago, 99% of the heat delivered upstairs, that furnace heats upstairs, has been delivered by the miner, so that the furnace hasn't turned on. So it's, okay, 10x oversized. It's crazy to think about. Andrew, as we wrap up here, and then work your way down after Andrew, what advice would you have for the Heatpunks? Sizing, unrelated to sizing, you guys are coming from the broader HVAC commercial space. We'd love your input and thoughts on what we should be paying attention to, what problems we should perhaps go tackle first. You've been to these AHR massive HVAC conferences, right? This is very different, so we'd appreciate some input.
Yeah, I mean, it's a big question. It's a very large industry. You mentioned AHR. There's 50 to 60,000 HVAC professionals who meet every year. There's a hashrate. I learned you're a chapter president and stuff. It's a very large established industry, and it's worth learning kind of how it works and the different players in it. And there's the MEP firms, and there's design build guys, and then there's sales engineers and design engineers and the people who build software and different load calculation methods and energy modeling. And it's very complex, so I think it's just worth kind of understanding how it works and how products get sold, and a lot of that's through these. It's very relationship driven industry. That's an important thing that I learned in the last couple of years being in this industry. It happens at golf courses. It happens at the expo. At the I'm sure table. You guys know this. It's a very wine and dine heavy industry, and so if you want to start getting spec'd into basis of design and then eventually getting procured by a mechanical contractor, you probably have to wine and dine. And so the next generation of equipment manufacturers that do this kind of thing and get UL listed and enable this future, you got to do that.
Yeah, I would just say, and this has been mentioned in some of the other panels too, is solve a non-Bitcoin problem for them. If it's somehow improving their maintenance, making lives easier for the facility staff, providing a source of revenue for the facility staff to then use to pay for deferred maintenance, something like that is going to go much further, particularly because I think just the amount of Bitcoin knowledge in the AEC industry is just minuscule. It just doesn't come up. So you have to kind of meet them where they are and give them a pitch that they are receptive to, and they want to reduce costs, they want to reduce maintenance and operations, and just kind of make things easier for their staff. So that's what I'd say.
Yeah, kind of piggybacking off what you were talking about, there's an HVAC rep network that's already very well established all over the country, right? They know all the nuances of every market. You know, they have teams in place, service teams in place. You know, they're kind of the ones that drive, you know, new technology adoption in the HVAC industry, I'd argue. You know, I think about like VRF technology comes to mind, variable refrigerant flow technology. It was invented in like the 80s, I think mid or early 80s in Japan. It took like 25 years before it was adopted in the United States, and then probably another 10 to 15 before it was like seen as another, you know, just another system, another tool that contractors and engineers were familiar with and comfortable with. So, you know, these things take time, I'd say, and there's already, you know, I mean, for those that sat downstairs, you know, we have great engineers out there already. We have great controls contractors and technicians that understand, you know, a lot of the other side of this, right? It's, I think, you know, with the open source, you know, pushing the open source mining to get to the point where we have the form factor and all the documentation to hand over to our sales reps and say, hey, go. And they have all these relationships to, you know, really, you know, deep in this commercial market to really, you know, boost adoption. So, and find the actual, you know, the best implementations of this. So, you know, once we get to that point, I think it'll be like rocket fuel, right? But anyway, that's what I got.
Gentlemen, thank you. We very much appreciate your expertise coming from the more broad HVAC space. So round of applause for these guys up here.